my goodness, do you smell that odor? Is it just me? I don't know. Somebody needs deodorant. Oh, I'm sorry, fella. I didn't see you there. I really didn't. Yeah, sure, Mr. Wara. Yes, no, really, you're you're kind of stinky. Oh, wow, I'm sorry. Hey, no, I totally get that. Trust me, I know. Yeah. I have a classroom of fifth graders. No, 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 no. Okay. Okay. Man, I really wish I could help you out there. Yeah. No, I guess bathing is kind of out of the question for you, right? I mean, yeah, it's a physical adaptation that you've yeah. I mean, it's not your fault, it's kind of programmed in your DNA. I mean, a physical adaptation that kind of keeps you safe. I get that. Yeah, I don't know what to tell you. I mean, what do you tell somebody, if they're kind of stinky? I mean, you know what I mean. Anyway, no, of course I'm talking about this guy here. I'm not talking about anybody else. But hey, my friends, it's not all about the skunk, dude, but it's really we're doing lesson 10.5. That's right. And you can see our topic. Woo, we're moving on to metric measures. I was waiting for that to come. It's here. We were working with customary units. Now, metric. For some of you, this might be the first time. I don't know if you've had metric units before. But let's go ahead and look at our essential question. My friends, you are my friends. This is what it's all about. This is our focus. This is our learning target. It says, how can you compare and convert metric units? This looks like a very similar, it's a similar learning target that we've had before, except this time we're looking at metric units. You know what I'm going to say next? That's right. It's time to unlock the problem. That's right, my friends. It's real world, baby. Real world. Real world. Now, it says here, using a map, Alex estimates the distance between his house and his grandparents' house to be about 15,000 meters. About how many kilometers away from his grandparents' house does Alex live? All right. It's a great question. Yes, it is. And it says underline the sentence that tells you what you are trying to find. Again, this is so easy. It says it right here. About how many. And what the key thing here is it says about how many. And that nice word about, let me mark this page up this time. Woo, yeah. And let's say that about, that lets us know that we're going to estimate. We're going to make a good guess based on mathematics and what we understand. When we estimate numbers, we look at it and we say, hey, about how many kilometers away, though, the entire question, what we're trying to find is, how many kilometers away from his grandparents' house does Alex live? So we have Alex lives in a certain spot, grandparents' house. We need to find out how far. I don't know why I was doing all those lines, but it just seemed like fun at the time. It does say, circle the measurement you need to convert. Okay, well, we talked about this before in the previous videos when we had ounces and pounds or gallons and pints and quarts, all that kind of stuff. Here we have meters, and over here we have kilometers. Okay, that's not the same unit of measure. It says the metric system is based on place value. Each unit is related to the next largest or next smallest unit by a power of 10. This is so important. I mean, where's my bell? Because this is key. I'll put a little star here. Each unit is related to the next largest or smallest unit by a power of 10. Well, let's go ahead and take a look at our chart down below here. Yeah, okay, I'm looking at it. It says one way is to convert 15,000 meters to kilometers. Okay, before we start into all of this, I think I need to explain this a little bit here about these units in the table. I'm sure that maybe some of you are looking at this and going, is this a foreign language? I mean, it looks really weird. It looks different. And it's important to understand what these units are and then again, how they're related. How are they related? Well, kind of think what's in the yellow. We kind of think of these are like base units. And base units suggest that we're going to be making comparisons based on that unit. It becomes kind of like the standard. And so each unit here is 1 power of 10 greater than the unit to its right and 1 power of 10 smaller than the unit on its left. You see here, this is showing our power of 10. Here we have meter, liter, gram. Meter is a unit of measure for distance, for measurement, and then the liter is for volume, and then the gram is for weight. And if you notice here, that means that this unit here, the decameter is 10 times greater than the meter. However, the meter is 10 times greater than the decimeter. And notice we're just throwing on the meter on the end because that's our standard Latin. I don't know if that's Latin or Greek root, which just means measurement. And so we keep going. There's another power of 10. So the hectometer is 10 times greater than the decameter. And of course, a kilometer, and we tend to say kilometer instead of kilometer, but the kilometer is 10 times greater than the hectometer. Now, what's interesting here, this is just like our base 10. You could almost think of this in a way is like our ones place, and then that's that place value, and then every time you move to the left, those units there are 10 times greater to the one on its right. So the kilometer here is the largest unit. Here's the largest unit that we have, and then that would make sense that way over here the millimeter is the smallest. And it's almost, when you think about our own place value, if this was like a decimal point, it's almost suggesting these numbers, they get smaller as they move to the right of the decimal point, and the numbers get larger as you move to the left. Because it's like a power of 10, it's almost like our own place value system where we group numbers based on a group of 10. Where you have 10 ones, then becomes 110, 10 tens become 100, just like that. Now there's a way that we can bypass this here a little bit too. So the decameter here, this is 10 times greater, then this is 10 times greater, and we get all the way to the kilometer. Well, that means the kilometer then is 1,000 times greater than the meter. Because since I have one power of 10 here, here's 1, and I'm just going to put my little 1 in there. Here's another power of 10. There's another one. And there's another one. And so it's almost like we have 3 zeros there when you think about it. 3 powers of 10 is just 1,000. So now we can say the kilometer is 1,000 times greater than the meter. 1,000 times greater. I'm hoping this all makes sense. I know this wasn't part of the lesson per se, I don't think, but I'm going to go ahead and continue. I think it's important to analyze this chart before we get going. So we understand that the milliliter here, then we could actually, as compared to the base unit, this is 1,000th the value of 1 meter. This is 100th the value of a meter. And then this is 1/10. See how we're going? These might look familiar. And here now we have, this is 10 times greater. That's why we remember 10 times greater. This is 100 times greater. And over here, this is 1,000 times greater than our base unit of the meter. I think we're ready to move on.
Boy, Mr. Moore, that was a long lecture.
I know, huh? I just really got crazy with the metric system. So let's look at step 1. It says find the relationship between the units. Meters, so some of this we did talk about. Meters are blank powers of 10 smaller than kilometers. We already kind of figured that out, didn't we? Yeah, we were looking at that. We know that a kilometer is 1,000 times, but when we say powers of 10, so powers of 10 would suggest that, no, we have 3 powers of 10. We can see it right there in 3. Meters are 3 powers of 10 smaller than kilometers because the meter's over here to the right. And the numbers get smaller. Remember, we had our smallest over here. We have our largest over here. So the value gets smaller as we move to the right, just like our place value. There are blank meters at 1 kilometer. Okay, so if we have just 1 kilometer, kilo actually means 1,000. So if you know what your meter is, you can just remember kilo means 1,000. That means I would have to have 1,000 meters. Okay, woohoo! Yeah. I'm liking this metric system. Okay, let's move on to step 2. Step 2, determine the operation to be used. Okay, if I am converting from a blank unit to a blank unit, so I will blank. Yeah, that's nice little language frame for us. I like it though, I do, because it makes us speak in complete sentences. Well, in this case, we're doing it based on the question. So let's look at the question. Here we go. The question said, using a map, Alex estimates the distance between his house and his grandparents' house to be about 15,000 meters. About how many kilometers? So meters is a smaller unit than kilometers. Therefore, I'm going to be converting from a smaller unit. Does that make sense? Meters are smaller. Converting to a larger unit. And of course, we always know, much like the customary units, whenever we do that, here in this case, because we're converting from a smaller to a larger, we're going to divide. And again, that same principle that we learned in previous videos is true. If we have more of the unit, we have a lot of meters, and we're going to be putting it into a larger one. The larger one is going to be able to group more of them together. So we're going to need fewer of the groups. So therefore, that's why I divide. And I only explain that to you so that you understand why. I know math, a lot of times we just, solve the problem, do the algorithm. But Common Core standards really emphasize that we think about what we're doing. Step 3, convert. Number of meters, we have 15,000. We already decided, right, that we are going to divide, so I'll put my divided sign in there. The meters in 1 kilometer we know are 1,000. We determine that. And of course, that means the number of kilometers that we're going to have, pretty simple, right? 15. Alex's house is 15 kilometers from his grandparents' house. I know, you might be thinking, is it really that easy? And it really, really is. Now, it does say here, Math Talk chose 2 units in a chart. Do they mean choose? Maybe choose would fit better there. Choose 2 units in the chart. Explain how you use powers of 10 to describe how the 2 units are related. Okay, well, if we go back up to the chart and we can see that they're related in a lot of different ways. Every unit is 1 power of 10 difference from the one to the left and to the right. It's either 1 power of 10 greater or it's 1 power of 10 smaller than the unit. Here the kilometer is 10 times greater than the hectometer and so forth. But we can also say, let's say we want to say how much larger is the hectometer compared to the centimeter. He's way over here. Okay, obviously the hectometer, because he's over to the largest side, he's larger. But how many powers of 10 larger? Well, we just count our powers of 10. 1, 2, 3, 4. He's 4 powers of 10 greater. 4 powers of 10, which 4 powers of 10 is just 10,000 because I have my 4 zeros. Each zero, that place value, represents a power of 10. Oh, it's that easy. That's right. So we can actually say that if you wanted to find out how many centimeters there were in 1 hectometer, now we can say, that's right, there's 10,000. Is that Mike saying? There's 100 of them in a meter, okay? That means there has to be 1,000 of them in a decameter, and that means there has to be 10,000 in a hectometer. Don't you love it? It's so easy. We don't have to memorize 1 quart is equal to 2 pints and 4 quarts in 1 gallon and all that stuff. We don't have to memorize these really odd units of measure. The metric system is just like our place value system. Woohoo! Yeah. I'm loving this video. Page Master. Okay. Oh, there's our friend. Hey, how you do? You feeling a little bit better? No? Oh, I see. Wow, I feel sorry for this fella, You're our feature animal of the day, and, my goodness, that look is just... Doesn't that look? He's so melancholy. He looks... I feel for you. But anyway, yeah, I'm probably going to go ahead and maybe move you here just temporarily. Yeah, because you're kind of guarding that nice little picture back there. We'll put a little miniature one there. There you go. All right, buddy. Hang in there. Here's another way. Use a diagram. It says Jamie made a bracelet 1.8 decimeters long. How many millimeters long is Jamie's bracelet? And it does say to convert 1.8 decimeters to millimeters. So step 1 says show 1.8 decimeters. Okay, like on that chart right up there. It says since the unit is decimeters, place the decimal point so that decimeters are the whole number unit. Okay. Step 2, cross out the decimal and rewrite it so that millimeters will be the whole number unit. Write zeros to the left of the decimal point as needed to complete the whole number. Okay. Step 3 says record the value with the new units. Okay, I don't know if the directions there were super clear. It would be 180 millimeters. So I guess the way I would think of this is the decimeter and millimeter, there's a difference of 2 powers of 10 or 100. And we do have it as a decimal. So another way for it to make sense too, for me, I'm sorry, this is how I'm thinking of it. Because I'm going from a larger unit to a smaller unit, I know I need to multiply. But that's what I'm doing. I'm going from larger to smaller, so I'm going to need to multiply. If I took 1 and 8/10 and multiplied, I could multiply that by 100. Now, why would I want to multiply that by 100? Because I'm going 2 powers of 10. I'm going to 1 power of 10 here. There we go. Draw my little arrow. And then I'm going 1 more power 10 to milliliters. Or it's millimeters, sorry. And so that's 2 powers of 10 times 10 times 10. So I have 100. And when I take this multiplied by 100, we know what happens to the decimal point. It moves 2 places to the right, and that's what we would end up getting. We'd end up getting our 1 time, and then our second time. Now our decimal place moves there. Here's my little loop-de-loop. That's right, little loop-de-loop in there, and I put my 0, and then the decimal point's already moved, so I have my 180. I don't know if I'm crazy about step 2 and the way that they describe those directions. Sorry, Mr. War is off the grid again. Okay, let's move on down. Oh no! What are you doing here? Again. Oh. Yes, you know what? You're doing this whole thing. You know, I know you're trying to prove that you're real. Yes, Mr. Unicorn. I'm sorry, Miss Unicorn. But you know what? You're not the feature animal of the day. I'm sorry. You're crashing in on our buddy over here, which I don't know if I ever got his name or not, but we'll just call him Mr. Stinky for the time being. It's his page. So we got to make you disappear here. Okay, what are you doing? You trying to show off that you're. Okay, I guess he's gone now. All right. Whew. Okay, relief. Let's get back to math. I don't know, maybe I hurt the guy's feelings. Oops. Sorry. Okay, now it says try this. Complete the equation to show the conversion. Here it says A, convert 247 milligrams to centigrams, decigrams, and grams. Okay? Now, again, what we want to remember here, so we're taking this quantity here and we're converting it to these other ones. We're going to convert it to centigrams, then we're going to convert it to decigrams, right? And then finally to grams. Okay, what's important to understand here, again, when we think of that metric chart that they gave us, is that grams is in the middle. Our base unit is gram, meter, and liter, and those are right in the middle. So you can think of any of the units are to the right are smaller, and any of the units to the left are larger. Therefore, with 247 milligrams, we need 1,000 milligrams to just make 1 gram. Okay, so that means the milligram, he's way, way, way over to the right. And we're trying to bring him to the left because we want to bring him to the centigram, which 100 centigrams is equal to 1 gram. 10 decigrams is going to equal 1 gram. So those units are smaller. So we are actually going from a smaller unit to a larger unit. Should you multiply or divide by powers of 10 to convert? We will divide. 247 milligrams divided by 10, well, that's just going to be 1 less, right? So we're going to have 24.7, 24 and 7 tenths, if you will, centigrams. Notice, now that number looks a little smaller here, but the unit is larger. That's why we need to divide. If we divide by 100, now this is another way to go straight from milligrams, okay, to decigrams without making 2 steps. So we're just going to divide by 100. Now the decimal place is going to move 2 times, so we're going to have 2 and 47 hundredths, or 2.47 decigrams. Remember that decimal place just simply moved to the left. It was here. We divided by 100, 110, and then another 10, another power of 10, giving us 100. That's what happens to the decimal point. Moves to the left when you divide by a power of 10. Now we have 247 milligrams divided by 1,000 because we're moving even further. And now we're going to end up with 0 here. We like to put in the front 247,000, or just simply 0.247. And you can see it moved 1 more time. That's all we're doing with the metric system. It really is a decimal point moving left, right. How many times? That's all we're really doing. B says convert 3.9 hectoliters to deciliters, liters, and deciliters. Oh my goodness. Okay, that's kind of weird. Okay, so let's take a look. First thing, if we're going from hectoliter, which is to the left of a liter, a deciliter is to the left, then we know that we're going, okay, the hectoliter, that we're taking a unit that is larger and we're going to be going to a unit that's smaller because, and then should you multiply or divide? Well, if we're going from a larger to a smaller. So we're going to be multiplying. Now, if you notice these weird units, HL, hectoliter, we're going to multiply by 10 because remember that deciliter is right next door. Didn't even know that's how you abbreviate deciliter, DA. Kind of strange. So here we're just going to have 39 deciliters. And then over here we have 100 because now we're going to the liter. And a hectoliter, if you go to liter, if you look on your chart, it's 2 powers of 10. So we're just going to have 390. And then finally we have this one here, hectoliter. And now it's interesting because we're actually skipping one. We're going all the way over to deciliter, and that is 1, 2, 3 powers of 10. So that's 1,000. That's correct. And so here we're going to have 3,900. Woohoo! Yeah, yeah. And I'm just, oh, not you again. My goodness, you have to be in the forefront all the time. I guess. Hey, whatever happened to our friend Stinky? I mean, our skunky friend? Hey, nothing? Oh, hey, there he is. Is that a figment of my imagination, or do I see a lot of skunks? Oh, that's you in there. I couldn't even tell. You guys all look the same. Very cool. So I see you found some people that are like you, so so they can all stand each other, if you know what I mean. Hey, all right. Well, I'm glad it's yes.
Another happy ending to our feature animal of the day.
Yes, you gotta like it. Woohoo! Okay, my friends. Hey, it's time for me to skedaddle. Now, live long and prosper.